Okay, geometry, we are in day one of the final semester review. We'll do 3 days of this, so this is part A. There are 50 questions on this review, so we'll try to do, I don't know, 16, 17, something like that per day. And I think what we might just do is, since this is 3 pages long, we'll just do like one front and back page each day. So we'll do through 17 today, I think. So this might be a little bit longer of a video, but we will get through it. So you'll need a copy of this or another sheet to write down. I have attached this to your Google Classroom page or this assignment tab, and let's go ahead and get started. So number one, this is all from chapter 4, which is talking about triangles. It's kind of the introduction to triangles. Number one says classify the following triangle by its angles and sides. Okay, so let's talk about angle classifications and classifying a triangle by its sides. Okay, so angle classifications. An angle can be acute, it can be obtuse, or it can be a right triangle. Okay, so normally we don't assume anything unless it's already marked on this triangle, but I'm going to go ahead on this one and assume that this is a 90-degree angle. So I'm going to say that this is going to be a right triangle. Okay, now that's one of its names. It's going to have a second name according to its sides. Okay, so naming a triangle by its sides, if all of the sides are exactly the same, this is going to be an equilateral triangle. Okay, so if all of those sides are exactly the same length, which doesn't look like they are, it's going to be equilateral. If two of the sides match, then it's going to be isosceles. Okay, and if none of the sides are the same measure, this is going to be scalene. Okay, so we pick a name over here, which we said was a, right. Blah, 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 blah. Don't look at that. We said that was a right triangle, and it looks like none of those sides are going to be exactly the same length. So this is going to be a right scalene triangle, okay? And that's what he's going to look like. All right, now number 2 is going to be kind of branching off of that, except they're giving us vertices. They're saying find the measures of the sides of the triangle and classify the triangle by its sides. So I want to figure out, according to this EFG, what the length of each side is, and to do that I have to use the distance formula. So here's my distance formula. You guys can probably maybe have this memorized at this point. X2 minus x1 squared, and then y2 minus y1 squared. Okay, so we're going to find each of the 3 sides. So one of the sides is going to be EF, another side is going to be FG, and then the third side is going to be EG. So let's do those. EF, FG, and EG. And we will write each one of those out. Big, long square root, long square root. Okay, so starting with EF. All right, from E to F, my second x coordinate I'm going to say is 1 minus a negative 3. 1 minus negative 3. Then I have negative 1 minus 3. Let's go ahead and write out what FG looks like. So FG, he is going to be negative 3 minus 1 squared plus negative 5 minus a negative 1 squared, and then EG, okay, x2 is negative 3 minus a negative 3, negative 3 minus a negative 3, and negative 5 minus 3. Okay, you could have done that in a different order or backwards, and it doesn't really matter, just because we're going to end up squaring it. So if you end up with a negative, inside of here, it's going to end up making it positive no matter what. So if you did like 3 minus a negative 5 or whatever, that's going to end up being the same thing, okay? So here I have 1 minus a negative 3, or 1 plus 3, which is 4. 4 squared is 16, okay? 1 minus a negative 3 is negative 4. Negative 4 squared is also 16. So this guy is the square root of 32. That's what he looks like. Okay, let's go down and do the next one. So negative 3 minus 1 is negative 4. Square root of 16, negative 5 minus a negative 1 is negative 4 squared, which is also 16. Okay, so at this point, one of these options I can get rid of. I know that this is not going to be a scalene triangle because 2 of my sides are already matching up. So at the very least, he's going to be an isosceles triangle. If this other one ends up being the square root of 32, he's going to be equilateral. Okay, so let's see what this guy is. Negative 3 plus 3. Is going to be 0, and 0 squared is 0. -5 minus 3 is -8. Squared is 64. So I have the square root of 64 or just 8. Okay, now the square root of 32 is not the same thing as 8. So we have two sides that are matching and two sides that are not. So this is going to be, or excuse me, two sides that are matching and one side that is not. So this is going to be an isosceles triangle. Okay, all right, moving on. Number 3, we want to find a measure of angle 3, okay, which is all the way over here at the other end, and the only two angles that I know are 110, and I know that this is 90 degrees. Okay, so let's kind of start with the 110 and see if we can come up with anything, to get us to angle 3. So if this is 110, this angle right here, this bottom one is going to be 70 degrees. And I know that because these two have to add up to 180 because they are on the straight line. So that is going to be 70. But then I look at these two little markings here, okay? This triangle right here, because of those two little markings, means that those two sides are going to be exactly the same, okay? And that means that the angles opposite those sides, if I do my little crisscrosses, those two angles are going to be the same. So angle 1 up here at the top is also going to be 70 degrees, okay? Now, why do we care about that? Because we didn't need to find angle 1. Well, it's going to help us because we're going to continue on and we're going to get down over here. This angle right here, if I add 70 and 70 together, that's 140. And all three of these angles inside of this triangle have to add up to 180. So if those two add up to be 140, this guy is going to be 40 degrees also, right? Or the rest of the 40, right? If this guy is 40, then this guy has to also be 40, right? Because those are vertical angles, they're opposite each other. And now I'm inside of this triangle where I have a 40 degree, a 90 degree, and angle 3, okay? So 40 plus 90 plus angle 3 has to add up to be 180, okay? 40 plus 90 is 130, and if I subtract the 130 over, angle 3 has to be 50 degrees, okay? Or I could have looked at this and said, okay, this is 90 degrees, 40 and 50 have to be the other 90, so angle 3 has to be 50, okay? So that was kind of a little bit longer. Moving on to number 4, identify the congruent triangles and name their corresponding congruent angles. So what we want to do here is write a congruent statement. So triangle whatever is congruent to triangle whatever. And it doesn't matter how we name them, we just need to make sure that we put them in the same order, okay? So I see triangle ABC over here, ABC, let's call him ABC, okay? So ABC is the order that I'm going in. You could go in a different order, but you just have to make sure that they match up. And what I mean by that is if we list A first here, over here, we know that A goes with F because they have the same one little dash marking, okay? So A goes with F. Oops, so I'm going to put F in this spot. I don't know why I'm writing A twice. So A goes with F. B, in this case, would go with D. And C will go with G. Okay, so if I write them in that order, it would have to go ABC is congruent to FDG. Okay, I could have gone GDF is congruent to CBA. It doesn't really matter, just as long as they're corresponding to each one. Okay, and name their corresponding congruent angles. So I would say that angle A is congruent to angle F. Just picking this apart. Angle B is congruent to angle D, and angle C is congruent to angle G. Okay, just kind of going in the order that they are in. Okay. All right, number 5, determine which postulate, if any, can be used to prove that the triangles are congruent. Okay, there are 4 of them, and they are side, 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 angle, side, angle, and angle, angle, side. Okay, we've talked about the ones that don't work, like ASS, the naughty word does not work for proving that these two triangles are congruent. So what I have right here is this top triangle, and I want to show that it is congruent to this triangle. Okay, now, one thing that is not marked that I do know is that this side for the top triangle is the same length as this side for the bottom triangle, right? So kind of if I would separate those two, I would have this going on here. This guy would match the bottom side of this one, right? If this is the top triangle and this is the bottom triangle, and if I separate them, then I have these two markings here, and I have this marking here, okay? Now, that looks like side, 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 but here's the problem. They are saying by using these markings that these two sides match each other, and these two sides match each other. Well, what I need to have happen is that this side matches this one, but that's not what this says. And I need to have this side matching this one, but that's not what that says, right? So this is not, these triangles are not congruent by any of these means, because side, side, side still does not work, okay? So what probably is, what could be happening with this triangle, for all we know, is this shape looks like this, right? Okay, those triangles are obviously not congruent, but this is fulfilling all of these requirements, right? This side is matching this one, and this side is matching that one, right? Okay, so we can't go by what it looks like. For all we know, that this is what the two triangles could look like, and those are obviously not congruent, right? Okay, all right, let's move on to example 6. So a lot of people think angle 1 is 40 degrees, and they'll just say, done, 40 degrees, all done. But here's the deal. So look, starting with this triangle down here, these two markings tell me that those two sides are the same, which means that the angles opposite those two sides are the same also, so this guy is another 40 degrees. Okay? If I add those two together, 40 and 40, that makes 80. Okay, with both of those together, that's 80, which means that this top guy right here is 100. Okay, the top angle in that triangle is 100 degrees because they have to add up to be 180. Okay, now what will this angle right here be? Okay, well, they live on a straight line, so this guy would have to be 80 degrees also, right? Okay, now I'm looking at, let me switch colors here. I'm looking at this triangle here, okay, and what I have, if I rewrite him, I have that this is 80, and these two sides are congruent to each other, okay, which means that these two angles have to be congruent with each other, okay? But all three of them have to add up to be 180, right? So if this is already 80 degrees, then these two will have to add up to be 100 degrees, okay? But since I know that they're the same, each of them will have to be 50, okay? So this angle up top here is going to be 50 degrees. That's what angle 1 is, okay? So be careful. It's not just always obvious the way that it looks. You kind of have to do a little bit of investigating. Okay, all right. Last one on this page, number 7. Find the value of x. Okay, this is the important part. This means that we're talking about an equilateral triangle. Okay, and when we have an equilateral triangle, we know that each one of those are all going to be exactly the same measure. Now, not only do we know that they're exactly the same measure, but if all three of those have to add up to be 180, then I knew each one individually is going to be a 60. Right? Okay. So what I can do, and you can take each one of these and add them together, like add this plus this equals 180. But why go to all that work? Why not just set one of them equal to 60 degrees, right? Each one of them is equal to 60 degrees. So what I want to do is I want to do this part right here, because 15x is the smallest one, right? I want to use 18x minus 12 and 10x plus 20 when I can use 15x. I can say that 15x has to be equal to 60, and just divide by 15, and x is going to be 4, right? Find the value of x is 4, okay? So I could have done that with any of these, and I would have gotten the same answer, but, you know, I'm trying to go the quickest route. I could have added all of them together and set it equal to 180, but I'm trying to go the quickest route. Any way you do it is going to be fine, but we did it fast, okay? All right, now on to chapter 5. We talked about relationships in triangles, okay? So this was the centroid and the angle bisector and all that good stuff, okay? So I don't know if you remember doing a sheet that said, like, rules of centroids and all that good stuff. So we're going to kind of refresh our brains here. Number 8, point E is the centroid of triangle ABC. And it says B to D, this whole length here is going to be 12. They want to know what the length of just ED is, okay? Our rules for centroids said that these guys were made from the medians. And a median was going from the vertex to the midpoint of the opposite side, right? So the opposite side, this is splitting him exactly in half. Okay, each one of those is splitting him exactly in half, and it's going vertex to midpoint, okay? So that's what a median does. Now, the rule is that this center point, or that centroid where they all come together, this distance from here to here is half of what this distance is from here to here, right? Okay, so basically what I have going on here is I have this segment going all the way through, and I have this sectioned off here, where this guy is going to be twice as long as what this is. And they all add up together to be 12. Okay, so what will this length have to be in order for them all to add up to be 12 and this to be twice as long as that? Okay, so you can kind of think about this. That relationship would have to be 8 and 4, right? 8 is double what 4 is, and added together would be 12. That's the only combination that I can do. So that means that ED would have to be equal to 4. Okay? All right, so that was the rule with centroids, okay? Number 9, they are saying that PO, this is an angle bisector. Bisector means it splits it exactly into 2 equal pieces. 2 equal pieces. Okay, so if these 2 pieces, those 2 angles are equal to each other, then I can set them equal to each other. So I would say 2x minus 10 is equal to x plus 15, and then I just solve. Okay, so I'm going to first, let's subtract the x to the other side. He's gone there. Okay, and then I'm going to, at the same time, I'm going to add the 10 over. Okay, so I will have 2x minus x is just x equals 15 and 10 makes 25. And I'm going to check to make sure, find the value of x. We don't have to plug anything back in. So x is 25, and that is it. Okay? All right, number 10, list the angles of GHI in order from smallest to largest. Okay? So they don't have any of these angles labeled, but what they do have is the sides opposite those angles. So like angle G is opposite of 3 inches. Angle H is opposite of 2 inches, and angle I is opposite of 1.2 inches, okay? So you can kind of see with angle G, like he's a really big angle because he is opposite the largest side, okay? So G is going to be the largest angle because he's opposite the largest side, okay? So we want to go smallest to largest, so which angle will be the smallest? 1.2 is the smallest side, so angle I, is going to be the smallest angle, okay? So we will a lot of times say angle I is less than angle, and then the middle angle will be whichever one is opposite to, which is going to be H, which is less than angle G, okay? So angle I is less than angle H, which is less than angle G. It's going from smallest to largest, okay? Now, the same way, number 11, it's talking about the shortest segments, okay? So my segments are PQ, QR, or PR, okay? Or I could call it RP if you want to write them backwards, it doesn't really matter. But we want to find the shortest segment, okay? So that's going to be opposite the shortest angle, kind of like it was up here, right? Shortest angle is 45, so the one opposite that is going to be side PQ, and that's what he will be. You could call it QP also if you wanted to, it doesn't really matter. But there's that, it's opposite the smallest side, okay? Number 12, if BD bisects, there's that word again, okay? And bisects means split in 2 equal pieces, okay? It is bisecting angle ABC. So this segment right here is splitting him into 2 equal pieces. Find the value of x, okay? Well, this segment right here is what the 2x plus 30 is, and this segment right here is what 3x minus 4 is, okay? If these angles are going to be the same, then their perpendicular pieces there are going to be the same as well. So I can just set those equal to each other. 2x plus 30 will be equal to 3x minus 4. Okay, and then I just combine like terms. So I'm going to subtract the 2x over. I'm going to add the 4. So 34 equals x. And find the value of x, and that's all I had to do. Okay, no plugging back in. All right, so x is 34. All right, next one, number 13, write an inequality to compare EF and GH, okay? And inequality means greater than or less than. It also means greater than or equal to or less than or equal to, but for this case, we're only going to do greater than or less than, okay? So EF is this side right here, and GH is this side right here, okay? So if I look at let's look at just this top triangle right here. Okay. EF, this guy is the one that's in question, okay? And it tells me that this angle right here is 20 degrees, okay? GH, this bottom side right here is what we're looking at, and it's telling me that this angle right here is 23 degrees, okay? Then it also does something up here where it talks about 6, okay? This refers back to the hinge theorem, okay, where I talked about, I remember talking about the hinge theorem, where we would talk about your doorway, and then here's your door hinging open. So here's your door, okay, and here's your doorway. So your doorways have to be the same size to start with, otherwise it's not on an even playing field. So if your doorway is, let's say, 5 foot wide, which is a big doorway, 5 foot wide, okay, let's say this door is opening only 40 degrees and this door is opening like 70 degrees, right? Well, the distance here is going to be longer than the distance here, okay? So what they're doing is they're starting us off with 6, and they're saying, okay, both of those are 6s. Well, that just sets the doorway in the right spot, okay? This angle is 23 degrees, okay, which is telling me that this side is going to be opposite the 23 degrees, okay? This EF is opposite the 20 degrees, okay? So which one is going to be bigger, EF or GH? Well, GH is opposite 23, so GH is going to be bigger because 23 is bigger than EF, okay? So that's kind of how that works. All right, we'll do 4 more, and then we will stop and start again tomorrow. Number 14, find the sum of the measures of the interior angles of a convex 16-gon, okay? We know that a triangle has 180 degrees, okay? A rectangle will have 360 degrees, okay? And the reason for that is because a rectangle is 2 triangles, right? Because 180 plus another 180 is 360, okay? If I have something that is a 5-sided figure, a pentagon, okay? The rule is that you take n minus 2 and multiply by 180, okay? In this pentagon, I would have 3 triangles, and each one of those triangles would have 180 degrees. So I would take 5 minus 2, which is 3, the 3 triangles, times 180, and I would figure out what that, whatever that was, 540, I think is what it is. Okay, so that pentagon would have 540 degrees for all of these angles added together, okay? Now, if I have a 16-sided figure, how many degrees will be in the inside of there? Well, I'm not even going to draw that out. I'm just going to use the rule. I would take 16 minus 2. This tells me the number of triangles that I will have. And then each triangle is going to be 180 degrees, so I just take that times 180, okay? 16 minus 2, I can do in my head, that's 14 times 180. Lots and lots and lots of degrees inside of there. So 2,520 degrees if I add up all of the angles of that 16-degree figure, okay? All right, 15, find the measure of angle X. I think we've done this figure before because I've seen this guy. So this is a 1, 2, 3, 4, 5, 6-sided figure. So all of those, let's figure out what they should add up to be. Okay, so following the same rule, 6 minus 2 times 180 is 4 times 180. So all of those angles should add up to be 720 degrees. Okay, so 7x plus 7x plus 4x plus 4x plus 7x plus 7x should add up to be 720 degrees because this is a 6-sided figure, okay? I'm going to do some simplifying to start with. 7x, 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 that's going to be 28x. And 4x and 4x is going to be just another 8x. Okay, so I'm going to simplify that a little bit. And then 28x plus 8x is going to be 36x. And then I just have to solve for x. So 36x equals 720. 72 divided by 36 is 2. So 720 divided by 36 is going to be 20. And that's what x is going to be. Find x. We don't have to plug back in or anything like that. But using that rule, n minus 2 times 180, and then set each, or add them all up together and set that equal to that. Okay. 20 degrees. Find the value of each variable. Okay, so we have x's and we have y's going on here. Okay, so let's see. Are we assuming that this is a parallelogram? I think yes, we are. So we're assuming that this is a parallelogram, even though it doesn't say that, but I'm going to say that this guy's parallel to that one, this guy's parallel to that one, okay? Now, the problem with this is I have x's here, and I have a y across from an x, okay? In a parallelogram, one of the things that you probably remember is that the opposite ones are the same as each other, right? Like these two angles, well, this angle here and this angle here will end up being the same size. So we will have that 3x equals y plus 9. But I can't solve that because I have two variables going on, okay? So I have to do something else first, and it involves these two x's, right? Those two x's. So what do these two have in relationship to each other, right? Like x plus 8, is this going to be the same angle as that? Well, if you just look at the angles, this is obviously a smaller angle than this one, so that's not going to work. But what we know is that consecutive ones, or ones that are right next to each other, add up to be 180 degrees. So x plus 8 plus 3x has to add up to be 180. Okay, so that's kind of how that works, all right? And then we just put stuff together. So x and 3x is 4x, and I'm going to subtract the 8 to the other side. So 180 minus 8 is 172, I think. And if I divide by 4, let's see if I can do that in my head. 17 divided by 4 is 4, because that's 16. 12 divided by 4 is 3, so 43 is what x is. Okay, now, since I have this written out, I can just plug 43 in here, okay? 43 times 3 is 129. You can check me if you don't think that I'm right, but I think that I am. 129, yes. Let's subtract 9. So then y will be 120 degrees. There he is. Okay, and x will be 43. Okay, last one. Find x and y so that the following quadrilateral is a parallelogram. Okay, so what they're referring to right here, this length of that diagonal is 3x. This length of that diagonal is 4x minus 3. Okay, in a parallelogram, those two are bisecting each other, which means that this length from here to here is going to be the same as the length from here to here. So I can set those equal. 3x has to be equal to 4x minus 3. Okay, those two pieces have to be equal to each other. Okay, and then let's go ahead and solve that one. So I'm going to subtract the 4x to the other side, even though it's going to give us negative 3x minus 4x is negative x equals negative 3. And x will be a positive 3. Okay, the y's, same thing. Y plus 3 is this length here. 2y minus 11 is that length there, and I know that those have to be the same. So y plus 3 equals 2y minus 11. Okay, and then I'm going to solve, so I'm going to subtract the y, and then I'm going to add the 11 at the same time. Okay, so the 11 is gone, so 3 plus 11 is 14. 2y minus y is just going to be y. So there he is, okay? All right, so that was the first 17 problems. Hopefully this isn't, I think this is a long video, but sorry. We will do the next page tomorrow, and 2 days left.